Hello, ladies and gentlemen. Today we are going to start with a very important chapter in physics, which is called light. Not only important, but also a very interesting chapter too. What is light? We all know. We can see light all around us. Like we get light from the sun, we get light from the bulb, and we also get light from the stars. Apart from these sources, we get light from other sources as well. There are a lot of other important phenomena related to light. Just like you can see this cat, it's seeing its image in the mirror. Even you must be seeing your image in the mirror every morning. So in this chapter, we will find that how we can see our own image in the mirror. You must have seen rainbow. This is also an interesting phenomena. You must have seen stars shining in the night. During the sunrise or sunset, the sky becomes red. And there are many more interesting phenomena related to light. We will understand all these things in this chapter today. There are two very important terms related to light. One is called reflection and the other term is called refraction. Please observe carefully that while listening it might sound same. Reflection, refraction. So firstly, in this chapter we will learn about reflection. Reflection of light. And once we learn reflection, we will move ahead and learn refraction of light. So let's start with reflection of light. Okay students, as you can see this, a well-designed beautiful room and you are standing here in style with your hat on. So when you are standing here, you can see all the things in this room. You can see this table, this sofa, this table. You can see also this bulb and also this painting and all other things in the room. So my question to you is that how can we see all these things? How? Can you tell me? I'm sure your answer will be very simple. Through your eyes. You will say, I can see all these things through your eyes. You are absolutely right. We can see everything through our eyes. But there is a small catch here. What's that catch? If I turn off the lights here, then it will be totally dark. Will you be able to see all these things in the dark? If I turn off the lights, then it will be total dark. And then can you see all the things? No, you can't. Though your eyes are still in the same position. So then why can't you see these things? Are you getting what I am saying? This means that just having your eyes open is not sufficient to see things. We can say that light should be there for things to be visible. It means light is important, only then we can see things around us. Are you understanding? Having light is very important. Now we will go a little deep into the technicalities. Now let's talk about this bulb. And we will go deep and understand how we can see. See, this bulb is glowing. So then what will happen is, it will give light. We have studied in lower classes that it will throw light in this manner. Okay? Light will come out in all the directions like this. The light rays emitted by this will reach us as well like this. So when this bulb light ray reaches our eyes, then we are able to see this bulb. Very simple. Light rays are emitted through this bulb. When the rays come out of it and reaches our eyes, then we can see this bulb. Okay? So when there is no light and this bulb is switched off, then there is no light ray coming out of it. And then there is no chance that it reaches our eyes. And so we cannot see it. So by now you must have understood. To see the bulb, it's important to have light and also to have eyes. So when the light rays reaches our eyes, then only we are able to see the bulb. Okay? This was about this bulb. If we talk about this bulb, then also the logic would be the same. Light rays will come out. The rays coming to our eyes will make us able to see it. Now let's talk about this sofa. You can see this sofa. How can you see this sofa? Is it that what is happening with the bulb, the same thing is happening with the sofa? Are light rays coming out of the sofa as well, which is coming to our eyes? No. You can understand that this sofa is not emitting any light rays. There is no light coming to our eyes. So then how this sofa is visible? So it's very simple. As this bulb is emitting light, so light rays are also hitting the sofa. Lot of light rays are falling on this sofa. So what sofa does is, it reflects some light rays. And this reflected light rays go to our eyes, and when these light rays go to our eyes, we are then able to see the sofa. Are you getting my point? Just as you can see this table, there is no light ray coming out of it. It's not a bulb from which light rays come out. But from this bulb, light rays are coming out of it, and when these light rays reflect, then we are able to see this table. Are you getting my point? So we can write here that we see an object when light rays from that reaches to our eyes. Right? The light ray may be either objects, self-light, or reflected light. Self-light or reflected light. So the thing which I have told you is written here. And now here, this bulb which is emitting light is called luminous object. Luminous object, which emits its own light. And this sofa does not emit its own light, but reflects others' light. We call it non-luminous object. So we can write the definition of these objects that luminous objects are objects which emit light of their own, Okay? For example, bulb, tube light, or sun. Sun, as you already know, emits its own light. And non-luminous objects definition we can write as non-luminous objects are objects which reflect light from other sources. Right? They do not emit light of their own. So, what are its examples? This sofa, this table, this painting. These all are examples of non-luminous objects or non-luminous sources. Luminous and non-luminous objects, best examples I will share with you here. Our sun is actually a luminous source of light. Luminous source of light. Okay? And this moon which we see in the night, Chanda Mama, is a non-luminous source of light. Non-luminous source of light. How? Let's see. Sun emits its own light. There is no doubt about it. It emits its light every day, and that light reaches our earth every day. So that's how we see the sun every day. So sun emits its own light. That's why it is called luminous source. And moon doesn't have its own light. Sun's light falls on the moon just like it falls on earth. It reflects the sun's light towards the earth. Okay? So in the night, we see only this light. So when the light comes from the moon, then we are able to see the moon. But the light coming from the moon is not its own light. It's a reflected light. So then what kind of source is moon? Non-luminous source of light. About light, we have learnt lot of things in the lower classes. First thing let us recall is light is a form of energy. It's not difficult, very simple to understand. You must have read in lower classes that there are various types of energies like sound energy, chemical energy, okay? Wind energy. So lot of types of energies are there. Similarly, light is also a type of energy. Second definition you must have read that light travels in straight line. Light travels in straight line. Light always travels straight. It doesn't travel in odd or zigzag ways. Okay? Third is light can form shadows. Light can form shadows. Shadows you already know. What it is? Light can make shadows. As you can see in this image, the person's shadow is falling here. Okay? If you want to know more in depth about this, then you can watch the videos of our lower classes. We have already explained in depth there. And also you must have read earlier, but maybe you don't remember them now. Reflection of light. Okay, students? Now we will see that how actually light reflects. To explain that thing, I want to show you a small animation. This is a wall and this is a small ball which will hit this. And then what happens, we will see. You already must be knowing that the ball hits the wall and then it reflects it. Bounces like this. Let's see it again. It hits, reflects, and bounces it again. So like the ball hits the wall and bounces, in the same manner, suppose a light ray is coming and suppose there is a bulb ray or a sun ray coming in this direction and hits the wall. Then just like the ball, it bounces. This process is called reflection of light. Reflection of light. Are you getting what I'm saying? It's very simple. If suppose lots of light rays come out, lots of rays come and are hitting on this wall, reflection of light. So we will see how the light reflects. To explain that thing, I want to show you an animation. There is a wall here and a small ball here, which will hit this wall. Let's see what happens. You can see the ball hits the wall and then bounces. Let's see one more time. Ball hits the wall and bounces. So just like the ball hits and bounces, similarly things happen with light as well. Suppose a light ray comes like this from, suppose a bulb, and a light ray comes from it which hits the wall. So just as the ball hits the wall and bounces in the same manner, light hits the wall and bounces. This is called reflection of light. So now let's go more in detail. What happens is obviously there cannot be only one light ray coming from the bulb. There must be many which must be hitting this wall. In this way, lot of light rays are hitting. I have drawn 3 light rays to explain you. So what happens when many light rays hit the wall? Some light rays will bounce, as I told you, but some light rays don't bounce. The wall absorbs them. Suppose the light rays on the upper side is absorbed And what has the wall done to two light rays here? Reflect. So what I am saying is, when the light rays hit the wall, some rays get reflected and some get absorbed. Also what happens is, some surfaces are shiny or smooth type, and some surfaces are dull or rough type. So if this wall's surface is very shiny or smooth type, then this wall will mostly reflect more light. Reflects more light. And if this wall surface is dull or rough type, then it will not reflect much of light. It will absorb lot of light. Reflects less light. As I have shown here, 4 surfaces. As you can see, this first surface is very smooth, very much smooth. As you can clearly see, slippery type. This one is less smoother. This is little rough, and this is very much rough, as you can see. So when on this surface any light ray comes and hits, then most of the light rays will get reflected. Reflect. Because this is very smooth. That's why a lot of light will be reflected. This is less smoother, so less light will be reflected. This is rough, so then very less light will be reflected, and this is very rough, so when the light rays will hit it, then very less light will be reflected. That is what I'm trying to say. Just look at this surface. This is a silver metal. Actually, it can be silver metal's polished surface or maybe aluminum's polished surface. You must have seen. This is very shiny. Its property is that the light which falls here mostly reflects. That's why polished silver or aluminum is a very good reflector. Very good reflector of light. Just as at home we have mirror where we see our faces every morning, is called plane mirror, as you must be knowing. Plane mirror. This plane mirror is a very good reflector. It's a very good reflector of light. Very good reflector. Very good reflector of light. On this, the light rays which fall, most of them reflect. So how this plane mirror is made, I want to tell you. Let's take a thin plate made of glass, which is called glass slab. Okay? On that, this aluminum or silver is there. We will do a thin coating of it on this glass slab. Okay? And on that coating, we will apply red color paint. That becomes a mirror. You must have seen mirrors from the back side. It looks red in color. So basically what happens, as I told you, is that there is a glass slab. Behind that, we do a silver or aluminum coating, and on that we put red color paint. Red color paint is put because this coating should not get damaged and should be protected. So now regarding this plane mirror, we are going to learn more in detail. So how the plane mirror looks and is made, that I have already shown you. And we will study more in detail about it further in this chapter. And I will represent plane mirror in a particular diagrammatic form, like this. So in this manner, we will represent a plane mirror. A small line and here small lines. This part will be the front side of the mirror. Front side of the mirror. Okay? Front side. Just like this. Okay, this mirror as we can see. And this will be the back side of the mirror, which can be in red color. Okay, which can be in red color. So this front side of the mirror, front part is called reflecting surface of the mirror. Okay. Reflecting surface of the mirror. Okay. Because any light ray which hits this part will obviously reflect, but the backside surface will never reflect. Terms related to reflection of light. So students, as you can see, this is a plain mirror. A light ray hits and reflects. So in this situation, we will define some terms which will help us understand more easily about light. Okay, I am defining the very first term, which is very easy and you already must be knowing it. The first term which I am defining is incident ray. Incident ray. Yes, you can guess the meaning by the name itself. This light ray which hits the mirror is called incident ray. A ray of light falling on mirror surface. Okay, a ray of light falling on mirror surface. Simple. Second term which we are going to define here is called reflected ray. Reflected ray. What is reflected ray? The light ray which gets reflected from this surface is called reflected ray. Reflected ray. So how can we define a reflected ray? A ray of light sent back by mirror. A ray of light sent back by mirror. So from mirror, the ray which is sent back is called reflected ray. Third point which we will define is called point of incidence. Point of incidence. This point where incident ray falls, where incident ray falls and reflected ray starts is called point of incidence. So a point of incidence can be defined as a point on mirror where incident ray falls. A point on mirror where incident ray falls. Next term which we will define is called normal. Now what is this normal? I will tell you. I am drawing this line as you can see. This dotted line is called normal. Its property is that it meets the mirror at point of incidence. Point of incidence with the mirror makes an angle of 90 degrees. So then we can say that normal is a line perpendicular to mirror drawn at a point or drawn at point of incidence. Okay? This point of incidence and this is perpendicular to mirror. Okay? There are few more terms. Let's have a look. The next term is called angle of incidence. Angle of incidence. Now what is angle of incidence? This is an incident ray and this one is normal. The angle which is made between them, this angle is called the angle of incidence. And generally it is denoted from the symbol I. I stands for incidence. And this is called angle of incidence. So how do we define angle of incidence? Angle between incident ray and normal. Okay, angle between incident ray and normal. Okay. Next term you must have already understood is the last term which is called angle of reflection. What is angle of reflection? The angle which is between normal and reflected ray, this is represented by the symbol R. What is angle of reflection? Angle between reflected ray and normal ray. Now we will see laws of reflection of light. When light reflects from the mirror, it follows some laws, some rules which are very important. So we will see that now. Actually, there are two laws. The first is known as first law of reflection. First law of reflection. What is first law of reflection? First, I will write it what it is. It says that incident ray reflected ray and normal lie in same plane. This incident ray, this reflected ray, and this normal, all the three lie in the same plane. To understand this point, I will make a diagram to explain. Look at this diagram. This surface is actually a mirror. Mirror. Just think that we are seeing this mirror from a different angle. So this is our mirror. An incident ray. Incident ray comes in red color, and this is a reflected ray. It reflects and goes away. This middle line is a normal in blue. This angle is called angle of incidence, and this angle is called angle of reflection. These three lines, red, blue and green, all these three are in the same plane. Incident ray, reflected ray and normal ray lie in the same plane. In this diagram also you can see that these three lines are coming in the same plane of the computer screen. So all the three are in same plane. The second law is more important than the first one. The second law is called second law of reflection. Second law of reflection. So what it says is very simple. It says angle of incidence and angle of reflection are equal. Means this angle and this angle both are equal always. Just to give you an example, if this angle of incidence is 30 degrees with the normal 30 degrees, then the reflected ray will also be 30 degrees to the normal. So angle of incidence is 30 degrees and angle of reflection is also 30 degrees. So both are equal. To give you one more example, if our angle of incidence is 45 degrees, then our angle of reflection is also 45 degrees. Both will be equal. Let's do a simple question. This is a mirror and a light ray is hitting the mirror and here makes an angle of 40 degrees. So now here the question is, find angle of reflection. You already know what is angle of reflection. So how much it would be in this case? We need to find out. Also draw reflected ray. We need to make a reflected ray also. So what will we do now? It's very simple. Whenever you are given incident ray and need to find reflected ray, then the first thing you should make is a normal where there is point of incidence. This will be the normal and also perpendicular to the mirror. Now you can see this angle. This angle is called angle of incidence. And what will be its value? Clearly you can see that angle of incidence is I plus 40. The sum of these is equal to 90 degrees. It means that angle of incidence will be 90 degrees minus 40 degrees, that is 50 degrees. So our angle of incidence is 50 degrees. Now how will this light ray reflect? It will reflect like this. And this angle here will be called as angle of reflection. So how much will be this angle of reflection? By the first law of reflection or by second law of reflection which we had seen says earlier as we had seen, says angle of reflection is equal to angle of incidence. It means that angle of reflection will be 50 degrees. Okay, angle of reflection will be 50 degrees. Very simple. So this is our solution. Let us do one more question. If light ray comes like this, then it reflects and goes like this, as we know. But let us observe an interesting situation. Let us say light ray comes like this. This is our incident ray which is perpendicular to the mirror. So it will hit the mirror and reflect. So how this will reflect is what we need to find. The question is, what happens if a light ray is incident on plane mirror perpendicularly? This light ray is hitting the mirror perpendicularly. So, what will happen?